Welcome to Beyond the Qubit. My name is Frank Dekker. I'm your host. What fascinates me at the moment about quantum technology? Where I get a lot of energy from is that I believe that we are witnessing a massive step change in quantum technology. I believe in 5 years' time, quantum computing will be proven. A, that it works, useful for early application. B, that it scales exponential. And C, that it will have the highest marginal compute per unit of electricity. And that's quite important, especially with the data usage of AI. The proof that quantum technology works will lead to a re-rating and the inflow of capital. We believe that around 2030 that is proven that quantum technology works. Now, why is that? At the moment we have very few logical qubits, but with 20 qubits, in theory, it should perform better than a laptop. And with 55 qubits, the compute power should be more than a supercomputer. But the problem at the moment is there are no useful algorithms where you can do computing with. And therefore, the expectation is that only with 100 logical qubits that we will see the first applications. At 2000 logical qubits, then that is when most applications will be enabled, including molecular modeling and optimization as a solution. By 2030, I expect that we see 100 logical qubits, and that will enable the first application. But also, when we reach 100 logical qubits in 2030, at that point of time, quantum technology has proven it could scale from 1 or 2 logical qubits up to 100 logical qubits, and that the applications work. But not only that it will also provide some visibility for further scaling. And by 2030, I believe that we will have visibility on scaling towards 1000, 2000 logical qubits. And I think the combination and the early proof that will lead to re-rating and an inflow of capital. And this fascinates me. What have I learned the last year? And the first thing, and I come back later to it, is I'm impressed with the various technologies competing with each other. At this stage, it's very difficult to say which technology will win out. On the positive side, there's a very strong European ecosystem of quantum enablers. Call it suppliers. Think about chip testing, control systems, interconnect, cryogenics, photonic components, and error correction method. I believe the forming of clusters of qubit chips scale out, and the improvement in error correction ratio are underestimated, and I love to study that. And also in the podcast, I love to do deep dives in those angles. I feel there are great suppliers with lower technology risk that have exposure to multiple quantum technologies. Last but not least, it is important for Europe to move from academics to building companies. European companies are disadvantaged versus US companies with the access of capital. Why is that? The biggest reason is that venture capital in the US is much bigger. 65 or 70% of venture capital globally comes from the US and only 15% from Europe. Why does this matter? Well, you might have great ideas and great entrepreneurs, but if you don't have access to capital or less access to capital than your competitors, they might be faster in, they could do parallel projects and be faster in innovation, or if they have access to capital, they could simply buy European companies. I see this as a risk for Europe. What outside factors have changed in the last year that might impact quantum? First of all, the growth of AI capex. And why is AI capex relevant? AI capex is money spent on high performance compute. And although that quantum is totally different than AI compute, I think for the longer term TAM estimate, it does matter. And for animal spirit, it's really helpful if more money is spent on high performance computing. National sovereignty is the second thing that really changed. And national sovereignty became increasingly important. And think about the battle between the US and China and increased tensions between the US and Europe. When quantum, in the chart here you can see three phases. The first phase I see is the R&D phase, and I think this is before 2030. After 2030 I expect the first applications, and after 2035 I expect mass market to happen, adoption to happen. And when quantum computing is economical, this will drive societal value and will accelerate the top line growth. I said in the beginning there is high technology risk, and we believe that the winner takes between 70 and 80% market share. And at this point it's unclear who will win out. But you can see we don't know which technology will win. But on top of that, it's also difficult to predict within a technology which quantum computing technology, which company will win. And this leads to very high technology risk. On the other side, what I find fascinating is that if you look at the suppliers, here there is potentially better risk reward. And why is that? Is some suppliers are enablers to multiple quantum technologies at the same time. So they have a few benefits, the suppliers. First of all, earlier monetization as they supply to the quantum computing technologies. B, lower technology risk. There's a higher probability for covering the winning technology. And 3, lower risk of choosing the right company within the technology. Now, there are 2 examples I want to share with you of companies. Orange Quantum Systems, they do chip testing, but their technology works for superconducting, but also for trapped ions and neutral atoms. Another company is QC Design. I interviewed Dant recently, the CEO, in the podcast. And what he explained to me is he does error correction simulation, but for most of the technologies out there. So then you don't take a bet on a single technology, and you don't take a bet on a single company within that technology, but you cover a wide range of companies and technologies. Why do we have high conviction that we reach 100 logical qubits around 2030? First of all, there are multiple companies who have a roadmap of reaching 100 logical qubits. But if we take a step deeper, there are 3 ways of getting to the 100 logical qubits. The first is scale up, the amount of qubits per chip or per unit. The second way is the amount of QPU chips per cluster. That's called scale out. And C, the error correction ratio. So how many physical qubits do we need for a logical qubit? And all 3 are making important improvements. And I feel that the amount of clusters, the scale out, and the error correction ratio, that the improvements here are real and they're underestimated. And on top of that, it is what is also helpful is that there are multiple technologies competing, and each technology has its own strengths and weakness for scaling up. I'd like to give you a few examples. For example, on the scale up, the qubits per unit, superconducting and neutral atoms do very well. On the scale out, photonics does really well. It's very neutral to very natural for photonics to transport photons and to interconnect. On the error correction ratio, physical to logical qubits, their neutral atoms and trapped ions have a benefit. So there are multiple technologies competing, and there are multiple paths that could lead to 100 logical qubits. And I think, yeah, this is why I think it's really fascinating to study the roadmaps of the quantum technology companies, and to track the progress that's made towards 100 logical qubits and 2000 logical qubits. And this is what we will do in the podcast. Maybe bringing everything together. So why does this all matter? I think in order to estimate the TAM, total addressable market, for quantum computing companies, I find it also, I'm fascinated by the mix shift of absolute dollar spent. And what you can see here in the chart is my estimate. And what you see is that when GPUs took off, they took market share in high performance compute spend from the CPU. I expect that longer term QPU takes more market share, but this will be very gradual. And there are two important dates, two important inflection points. The first inflection point will be when the industry reaches 100 logical qubits. And the second inflection point is when we reach 1000, 2000 logical qubits. I expect that to be around 2035.